one of the use cases that we have been dealing with in PQ React. And it's mainly focused on the application of post-quantum crypto on smart grid deployments. First, we think that this is a very relevant use case in the sense that we are dealing with an environment which is usually provided with networks with very low capacity, and processors in the smart meters also provided with very low processing capacity. So going to post-quantum crypto tends to be a demanding process. Usually, this kind of deployments rely on symmetric crypto. But the firmware update process, which is mandatorily to be performed relying on asymmetric cryptography, protecting the firmware delivery and so on. The firmware tends to be signed only once by the utility, but in some deployments it is also signed by the meter manufacturers. And the private key is managed also, only by the utility. Okay. Public key is distributed to the meters only for verification purposes, and in these scenarios, the firmware update process tends to be by itself, not considering the cryptography, tends to be quite demanding because of large images, because of the low processing capacity of the network, because of the topology of the network. The process tends to be quite demanding, and going to post-quantum crypto could be also more demanding. And based on this, on the current standards, this is protected by elliptic curve DSA, just because it is providing better performances and better sizes for this environment. And this image, we have a very simple schema on the involved entities. Once the meter manufacturer gets a new firmware image, the firmware image is provided to the utility. The utility takes the responsibility to sign the firmware before the deployment. The deployment is not directly performed to the meters. It requires an intermediate component, which is the data concentrator, and then the firmware is deployed to the smart meters. The responsibility of each of the components is the utility management on the systems has a responsibility to generate the asymmetric keys, the private-public pair, to manage in a secure way the private key in order to maintain the security and so on, and then to deploy the public keys to all the smart meters required to go ahead with the verification processes. It's also in charge of the firmware images management and so on. The data concentrator acts as a gateway between the two worlds in this scenario. On one side, we have the connection between the utility remote systems, where the connection with the DCs is by regular IP networks, where we are not going to have any performance issues. And then the data concentrators communicate with the smart meters just by means of prime DLMS networks. This usually goes just by the electric wire, and the performance here is quite low. And the smart meter, which, as I mentioned before, tends to have a very low processing capacity. It's in charge of going ahead with any order provided by the DC, handling the public key and its security storage and the secure storage, and is in charge of the verification of the firmware before going ahead with the update processes. Once we have the scenario, we can identify 3 impacts on the management of the smart grid deployment. First one is the firmware public key update. Once the smart meters needs to be provided with a post-quantum crypto key, it might have some impact because just of the sheer size of the public key. Going to post-quantum crypto is going to have much larger keys, and this is going to have some kind of impact on the network. And this is something that is required to be performed on a regular way on the deployments, whether it is because of just C crypto policy periods, whether we have some kind of private key compromise, just for instance on the manufacturer's side, or just because of some kind of algorithm update, which it tends to be something possible on the post-quantum world. Another impact is the firmware image delivery to the meter. By itself, this tends to be a process quite demanding, just because of the size of the firmware. Okay, but considering the post-quantum crypto digital signatures size, the size of the firmware itself is going to be incremented. This, in the end, this is no, the analysis is not so direct, but it will depend on the size of the specific firmware. It is not the same depending on the manufacturers of the meters. It might also depend on the algorithm that we are relying in order to go ahead with the verification. But the impact could be quite relevant, because we can have an increment on the number of failed meters, and having failed meters updated can have an impact on the security. We can have an impact on the packet resending, which can also impact on the management on the network, and an increment on the full process time required to go ahead with the firmware update on the network, which might have some kind of impact on the utility when performing other network management. I mean, in the end, the utility needs this network in order to manage all the smart meters, to get the billing details, to control the electricity, and so on. And third impact is related with the signature verification itself. As I mentioned before, the meters usually have a low processing capacity, and this might have an impact on the firmware deployment itself. In the end, based on some of the tests that we have been performing also in PQ React with the colleagues from Habit, this probably in the end it is not going to be so impacting, but it's also something to be considered. Now, for the pilot itself on the project, we have been in contact from PQ React with several utilities in order to try to collaborate with them and to raise awareness on the utilities and on the standardization bodies that the post-quantum crypto is something that it is going to be mandatory in the short term. First thing for sure, because of security reasons, in the end, the firmware deployment needs to remain secure, and going to post-quantum crypto is going to be mandatory. But also because at some point we are going to have a lack of standards supporting classical crypto, and also because of European regulations. At some point in 2035, EU is going to make mandatory to go only for post-quantum crypto. The utilities are collaborating with the project on the ideal scenario would have been the utilities having some kind of implementation on the real smart meters and so on, but this is not feasible for the time being. Utilities have been collaborating with the project, just providing logs from real deployments based on the current cryptography, on the current standards, having data from symmetric keys update, having data from real firmware update processes, and we have been working on provide them with some kind of extrapolations so that they can have a first image on the impact of post-quantum crypto. So we are processing the logs, and after processing the logs, we have some tools in order to extrapolate this data so that they can imagine what the impact will be. And the last thing, and I think it's quite a relevant achievement for the project, with one of the utilities, we are being able to push on the standardization body, on the DLMS, on the prime standardization body, which are currently dealing with some cybersecurity issues, to make them aware of the post-quantum crypto issues, and that they have to start considering right now which modification of the standards are required in order to be able, in the near future, to deal with post-quantum crypto. And this is not only something dealing with the performance and the key sizes and so on, but this is something that has some impact in the crypto agility side. Just for instance, in the current standards, they are currently supporting only 4 bits in order to specify which crypto suite they are relying in order to protect the deployments. And for sure, in the short term, this will be not enough if we are going to consider the current number of post-quantum crypto algorithms available, or if we are going to consider hybridization. It's something to deal with in the standardization process. Last thing, in order to provide with the utilities with some kind of real data, we have been working with them in order to have extrapolate the impact just by getting data from crypto processes, from publicly available databases, from EVAX and from the SU, and providing this data to the utilities so that they can use it based on the data that they have from classical crypto, what kind of impact it will have going to post-quantum crypto. Okay, and that's all.